Assalamualaikum warahmatullahi wabarakatuh. Thank you to our lecturer, Dr. Nur Atirah binti Muhammad Taib, for giving us opportunity to talk about molecular spectra. I will introduce our group members. Nur Ifah Ain binti Hasmuni 1171457, Atia Sakinah binti Masran 1171460, Nurul Nabila binti Ma'idin 1172437, Syadatul Husna binti Ahmad Tarmizi 1171471. Molecular spectra. It is a result from the absorption or the emission of electromagnetic radiation as molecules undergo the changes from one quantized energy state to another. There are two primary sets of interaction to observe the molecular spectra. This is the theory of molecular energy spectra and the limitation imposed by law of quantum mechanics. Rotational energy state. It occurs when a molecule undergoes a transition from one rotational level to another. This is the quantum mechanical selection rule. Firstly is for the transition between two rotational energy levels of a diatomic molecule. Secondly, for transition from energy level donated by J to J plus 1.
Non and quantized vibrational energy can be altered if the molecule acquires energy of the proper value to cause the transition between the quantized state. Then the energy we allow energies are going to follow equations. This is the equation that we need to follow. When n is equal to 0, it will consider the ground state. Therefore, the ground state energy is half h for f. This means that the molecule is going to sit there and vibrate even it's at a ground state. It's not going to keep vibrating. It's often called the 0 point energy, and there are a lot of supercussion for it. Besides, at the energy level spectrum, there is a selection rule when the ends can be only changed by at the most one. The selection rule for the transition is delta n is equal plus or minus 1. Is the energy of the n absorbed photon is E photon is equal to delta E vibrates or equal to HF. We use this equation at the energy level spectrum. This is the absorption of photons in pictures.
With the electronic energy state and energy state of real atomic molecules. Okay, so basically the energy interaction between the nuclei and the electrons in the diatomic molecules are more complicated and difficult. So, the most usual used method to consider the electronic energy state is by using MO approach, which is molecular orbital approach. Okay, in molecular orbital approach, the wave function of the individual molecules atoms are called as the atomic orbitals AO. This AO will combine and subject to the suitable mechanical and symmetry consideration to form a group of molecular orbitals, which is this form group of molecular orbitals can scope extends across the molecule's entire nuclear structure rather than being centered around a single atom. And then in terms of electron transfer between the two MOs, molecular electronic transitions and the resulting spectra can be represented. Okay, so that's all for the electronic energy state. Next, move on to the energy state of real diatomic molecules. Okay, for this energy state of real diatomic molecules, the rotation, vibration, and electronic excitation are taken into account, which is will give this equation. And then mostly in complex molecules, they may have many vibrations modes, rotation modes, and else. Thus, the combination of these different modes leads to the smearing of the discrete system, which is this discrete system may lead to the broad bumps appears rather than discrete lines. Okay, next, to find the total energy of a molecule in terms of its vibration and rotation, we can ignore the electronic excitation, which is will give this equation. Okay, so basically, a molecule in a given electronic state will simultaneously processes discrete amount of rotation and vibration energy, which is very distributed to a large number of rotation and vibrational state, energy state for a set of molecules, which is that energy electronic state change with electronic transition will be followed by changes in both rotational and vibrational energy according to the proper selection rules. Okay.
Okay, for the next part is difference between atomic spectra and molecular spectra. For the atomic spectra, transition of electron between electronic energy levels in isolated atom. But for molecular spectra, it is transition in molecule with two or more atoms. It's different between the atomic spectra and molecular spectra. And for the atomic spectra, it is a study of EM radiation that observed and emitted by atom. But instead of molecular spectra, the study of EM radiation is observed and emitted by molecules. You see the difference between atomic spectra, it is observed and emitted by atoms, while molecular spectra, it is observed and emitted by molecules. And then for the atomic spectra, it determines the types of atom present in samples. And for the molecular spectra, it determines the structure of molecules present in the samples. And last but not least, for the difference for atomic spectra and molecular spectra, the atom move to an excited state from a ground state, while for molecular spectra, the molecules move to an excited state from a ground state. So that's all for the difference between atomic spectra and molecular spectra.
That's all from us. Thank you.